Welcome to saitechinfo, dear UPSC, TNPSC, NEET and JEE aspirants and school and college students.
Hi my dear students. Today I'll be discussing about Ostwald's dilution law. It is given by this equation, that is alpha is equal to the whole square root of Ka divided by C. Here alpha is nothing but degree of dissociation. Ka, that is the dissociation constant of an acid. C is the concentration in terms of moles per liter, that is molarity. First of all, let us try to understand what is alpha. It is the extent of dissociation. To what extent an acid or a base or an electrolyte gets dissociated. It can also be called degree of dissociation. It means it is the ratio between the number of moles dissociated to the total number of moles present in the system. Therefore, alpha is number of moles dissociated divided by total number of moles. In the case of weak acid, you cannot anticipate all the moles of weak acid will get dissociated. Only a few can be dissociated, and that is why we obtain this as a ratio. But in case of strong acids and bases, they get completely and readily ionized. In that case, all are dissociated. It means the alpha value is equal to 1. For weak electrolytes, the alpha is always less than 1, but for strong electrolyte, alpha is 1. Do you understand this? Right. Now, let us consider acetic acid, a weak acid. Let us consider the dissociation of this weak acid, that is acetic acid. As I already given an explanation about the weak acid, it has got the least tendency to get dissociated, and they don't readily dissociate. So being weak acid, it is dissociated to H plus and acetate anion, CH3COO minus. Now the dissociation constant from the law of mass action can be worked out. That is dissociation constant Ka of a weak acid. It is nothing but the ratio between the product of the concentration of the product and the product of the concentration of the reactant. Now which are the product here? H plus and the CH3COO minus. So product of the concentration. So H plus concentration into CH3COO minus concentration. That concentration is represented by a symbol, that is a square bracket. When I put H plus within square bracket, that indicates the concentration of H plus. Then concentration of CH3COO minus, that is represented as square bracket here. So this is the product of the concentration of the product divided by, because I said ratio, divided by the concentration of the reactant. So here you have got only one reactant. If there are two reactants, then product of the concentration of the reactants. So you have got only one reactant, so you can put directly the concentration of the CH3COOH. I hope now it is very clear that Ka, the dissociation constant of the weak acid, is nothing but the ratio between H plus concentration and the CH3COO minus divided by, and this one CH3COOH concentration. I hope now this is pretty clear. Okay, right. Now let us come here. See, CH3COOH, that is the reactant, H plus product, another product, CH3COO minus. The initial number of moles, initially, probably let us start with 1 or 100 molecules. Let us start as a ratio, so 1. And because initial concentration will be more, is it not? Because when we compare thermodynamics and kinetics, in thermodynamics, they always worry about the completion of the reaction, to what extent the reaction has taken place. But in kinetics, they worry about only the speed of the reaction, how fast the reaction takes place. So that makes the difference between kinetics and thermodynamics. So here under thermodynamics, we need to talk about this initial concentration. The initial level of moles per liter of acetic acid is 1. Let us take 1 as a whole quantity. And as I already suggested, that is being weak acid, it undergoes what? Very weak dissociation. So alpha amount has been dissociated. So let us put degree of dissociation of CH3COOH is alpha. So alpha amount of reactant has been dissociated. And the number of moles at equilibrium means the remaining number of moles, is it not? So the remaining number of moles will be in terms of alpha 1 minus alpha, is it not? Now the equilibrium concentration, usually the concentration here we call it active mass. So the active mass is equal to the concentration into alpha term, here 1 minus alpha, so C into 1 minus alpha. So similarly we have to work out for H plus. Initial number of moles, that is when T is equal to 0, when the time is equal to 0, that is initial point. There is no H plus formed, is it not? Because I said that T is equal to 0. The reaction has not yet started. And similarly CH3COO minus, okay, so that is also 0. And what about this? Degree of dissociation, here it is alpha, I think that is here. This is also, after certain time, number of moles at equilibrium will be alpha and alpha. Okay, so now that is alpha moles are dissociated. After alpha moles are dissociated, originally this is 1 minus alpha, so you can put 1 minus alpha. So Ka is equal to, and the concentration term of this one into this one. So C alpha into C alpha whole divided by 1 minus alpha into C. So C can be cancelled. So alpha into alpha squared C divided by 1 minus alpha. So here the alpha is very small compared to 1, and therefore you can make it as unity. So 1 minus alpha is approximately 1. So you can put Ka is equal to C alpha squared, and alpha squared is equal to Ka by C by rearranging. Then alpha is equal to the whole square root of Ka by C. Okay, so this is called Ostwald's dilution law. Now what is Ostwald's dilution law? Alpha is equal to the whole square root of Ka divided by C. In case of base, it can be replaced by Kb. Instead of Ka, you can put Kb, and once again you can put alpha. So alpha is equal to the whole square root of Kb divided by C for weak base. Are you able to follow? I hope you should have enjoyed this lecture. Please go through all these important points. So this is the Ostwald dilution law formula, okay, and this is Ka, okay, and this is the table you have to remember, and this is the derivation part of it, okay, right. Thank you.
யாம் பெற்ற இன்பம் பெருக இவ்வையகம் என்பதற்கேற்ப please subscribe if you like our educational contents and share with your family and friends. Thank you for spending your valuable time.